Hello everyone. So today we are going to create game of life 3D simulations from the simplest possible starting conditions. Cells with one neighbors getting born with a single cell at the center of the simulation. And in itself, it doesn't produce such interesting results. There are these 3 by 3 cubes all around the simulation. But if we examine these, we can see that there are a specific count of neighbors which are going to allow us to create much more interesting results. For example, if we allow cells with 6 neighbors to survive to the next cycle, we can see that the very corners of these 3 by 3 cubes get to survive. And this creates already much more interesting patterns for the future cycles of the simulation. And most of the time we see that some cells survive for 2 cycles. We can see them here with the darker blue color. But on some rarer occasions, we can also see that there are cells which survived for 2 cycles, and maybe even more if we continue right here, 3 cycles in the simulation. And this don't seem to create repeating patterns like when we have only cells with one neighbors getting born, but rather this complex large structure which grows and then creates these remaining patterns all around the cube-like structure. There are also some other key numbers we can see here. For example, the number 10. And if we enable this rule, we can see that this kind of structure remains from the 3 by 3 cubes. And we get to see a completely new kind of pattern evolve from this one. And this also doesn't seem to repeat, but rather creates this thinner outer edge, which remains, and then in the future cycles, it gets completely transformed into a new kind of pattern. And we can also, of course, combine these rules we have just found. So if we enable both and start from the beginning, we get to see that the 3 by 3 cube gets to remain this kind of outer edge for the cube. And of course, once again, we get to see that this produces a new pattern, and it doesn't seem to repeat either. Here is actually quite an interesting pattern in the previous step. So it gets this disc-like structures on the edge of the cube, and these are symmetrical 2 ways. So quite interesting in-between pattern here. But this does seem to completely erase itself for the future cycles, and we get a completely different pattern for the next ones. Here is also somewhat similar pattern, but more of this round-edged cube, which gets produced on the later cycles. Here we also saw that some cells survived for 2 and even more cycles with this rule set. It seems that in the quite center, or now it's actually more on the edge, but earlier it seemed that in the center there are these cubes which get to survive for more rounds. And of course, when we get the structure this complex, there would also be new numbers which would affect on the life cycle of this complete structure. But when we start from the basics and look at these 3 by 3, it's easier to start to understand how these patterns evolve. Also, there are bigger numbers we can use for this. So right now, this is a hollowed out cube. So if we go to the previous step, we see that in the center, there is not actually a cube. So for this cube here, there are actually 16 neighbors. So we can also enable that one and see from the beginning that now this cell gets to survive for the next cycle. And again, we see that the new kinds of pattern evolves from this one. And also we could introduce a birth rule here. So from the 3 by 3, we see, for example, that for this very center outer edge, there's going to be cells with 9 neighbors. And if we enable that birth rule, we get to see that new cell gets instantiated here. And now that we have this 16 rule here also, we see that there is a few cells which have survived for 2 cycles. And now we also get to use this larger number in addition to the new birth rule to create these new patterns here. We can also think about what happens on this very phase when we transfer to the 3 by 3. So if we apply a little bit of loosening here, we know that there is no cell in the center. And if we wanted to make that one survive, we would need to use the cells with zero neighbors surviving. So if we start from the beginning, we can see now that if the center cell actually survived, and now on the next step it died. But if we want also that one to survive, we can enable the rule 26 neighbored cells for survival. And now we see that the center cube actually survived for 2 cycles. And there seems to be countless variation of these kinds of rules we can build here. And now we get to see these cells which survive quite a while, even in the simulation, when we use these ones. And of course, once again, we can combine these rules, for example, with the earlier cells with 6 neighbors getting born to get new patterns once again. And it seems that even these cells with 1 neighbors getting born can be quite interesting in the full 3D simulations when we combine it with specific survival values for the neighbor counts. And there are countless different variations of patterns which we can find from there. But I think this is all for this video. Thank you a lot for watching. This simulation is available for PC, Android, and iOS with the download links in the description. See you in the next one, and bye.